this example, we consider what happens when we take a piece of iron, and that piece of iron is at a pretty high temperature here, 100 degrees Celsius, and we're going to mix it with an equal mass of water, and the water is only at 20 degrees Celsius. And our goal is to see what happens to those temperatures, what does the equilibrium temperature turn out to be, and how does the change in temperature of each of these substances change. So let's go ahead and start the simulation. So we put in the container, and we've got that iron that was at 100 degrees Celsius. We have equal masses of both the iron and the water, and we can see what happens to the change in temperature of each of these substances and what is the equilibrium temperature. All right, so our experiment is complete, and we see that the equilibrium temperature is 27.75 degrees Celsius. So the equilibrium temperature is definitely not halfway between their temperatures. So the iron was at 100 degrees and the water was at 20 degrees Celsius. So the change in temperature of the iron is greater than the change in temperature of the water. The iron changed from 100 degrees Celsius down to 27.75, while the water changed temperature from 20 to 27.75. So much different in terms of their change in temperature. And that's related to the specific heat capacity of these substances. So iron has a much lower specific heat capacity. It's 0.449 joules per gram degree Celsius, compared to water, which is 4.184 joules per gram degree Celsius. So it takes a lot more energy to change the temperature of water compared to changing the temperature of iron. And so the iron is losing energy, and it's giving its energy to the water, and so the amount of energy lost is equal to the amount of energy gained. The calorimeter is making sure that that energy lost is equal to the energy gained. But even though the amount of energy lost is equal to the energy gained, the change in temperature is going to be different. So as that iron loses energy, it changes temperature by a greater amount, even though it loses the same amount of energy that the water gains. And as the water gains that energy, it changes temperature by a smaller amount.